The James Webb Telescope is NASA's biggest and most powerful telescope. It is 21.3 feet across and it's comprised of 18 deployable segments. Its 5-layer sunshield is as big as a tennis court. This telescope contains 4 important scientific instruments in its structure. These include a near-infrared camera, a near-infrared spectrograph, a mid-infrared instrument, and a near-infrared imager, and slitless spectrograph with a fine guidance sensor. With these, it can view visible, near-infrared, and mid-infrared wavelengths. It is currently orbiting the Sun around the second Lagrange point. With its size and its ice-cold temperature, it gave engineers an extraordinary challenge. Although it is most often compared to Hubble or seen as its replacement, it is more than that. As stated, James Webb uses an infrared camera to capture photos, whereas Hubble captures photos mostly in optical and ultraviolet wavelengths. Not only that, but it also has a mirror size much greater than the Hubble, allowing it to collect more light and see further into space.
Webb is an international collaboration between NASA and its partners, the European Space Agency and the Canadian Space Agency. It took thousands of engineers and hundreds of scientists to work on and develop this telescope. It took 300 universities, organizations, and companies across 29 states and 14 countries. Its first launch from French Guiana on December 25, 2021. It went under 6 months of commission in space. During this time, it had to overcome 344 single points of failure in order to unfold, and any one of these failures could have jeopardized the mission. It also had to cool down to its operating temperature of 7 Kelvin, align and calibrate before it could take any images. Its first images were released July 12, 2022.
The James Webb Telescope plans to study every phase of cosmic history. It will observe these phases from within our solar system to the most distant observable galaxies of the early universe. It will be used to understand the origins of our universe. Webb will gaze into where the very first stars and galaxies formed over 13.5 billion years ago. Today we can see the UV and visible light emitted from their first luminous objects, redshifted by the universe's continual expansion as infrared light. This telescope is designed to see this infrared light with never-before-seen resolution and sensitivity.
Scientists will use Webb to study planets and other bodies in our solar system to determine their origin and evolution and compare them with exoplanets. It will observe these exoplanets found in their stars' habitable zones where a planet could have water on its surface and can determine if and where signs of habitability may be present. Using transmission spectroscopy, it can examine starlight filtered through planetary atmospheres to learn more about exoplanets' chemical composition. We've been able to use these techniques before, but with Webb, we have a lot more power to see things that were previously too dim. This image is Webb's first deep field photograph. It is so far away from us that nearly everything shown is warped from gravitational lensing. It is the deepest and sharpest infrared image of the distant universe to date, and there will only be more to come.